Hi friends, in this one let's answer these questions from the 1997 AP Calculus BC multiple choice section, question 21. Which of the following is equal to the area of the region inside the polar curve r equals 2 cosine theta and outside the polar curve r equals cosine theta? First of all, it really does help if you understand how to do at least a Cartesian representation of the curves, because they can help you decide on the boundaries for integration. So I'm going to plot 2 cosine theta, and I'm going to plot cosine theta this way. And when I look at this, it tells me something important. You see, the curves are symmetric about x equals 0. So specifically, that means the following. This value right here, this is negative pi over 2. Negative pi over 2. It also tells me then that the following is true. This value right there, that's pi over 2, positive. It also means the following then, that here, this is 0 right here. And I can tell that it's symmetric and that the black curve is always above the green curve. I want to use symmetry, because what it tells me then is I don't have to integrate from negative pi over 2 to pi over 2. I can integrate from 0 to pi over 2 instead and simplify the process. So I'm going to proceed as follows. I will say a is equal to 2 from symmetry times 1/2 from the formula when you're doing polar integration, and then definite integral, 0 in the lower limit, and then pi over 2 in the upper limit. And now you're going to do the bigger one minus the smaller one. The bigger one is the black one, okay? I want to be very clear. This graph, remember, this is not the polar representation. This is the Cartesian representation of the curves. And then from there, I'm going to define. I'm going to do the bigger one, which is going to be 2 cosine theta squared minus the smaller one, which is just cosine theta, this whole thing basically this way squared, and then theta over here. When you're squaring the cosine function, the convention is to just write it this way, okay? And then you're going to have to distribute that 2 in the exponent over to the 2 and the cosine individually. So that means that the next line I would have the following. 2 times 1/2 is a 1 out front, definite integral from 0 to pi over 2. And then this here would be 4 cosine squared and then theta minus cosine squared and then theta and then d theta this way. Now simplify this. You're going to have the definite integral from 0 to pi over 2. 4 cosine squared minus cosine squared is 3 cosine squared theta and then d theta this way. And then this will give you with the 3 on the outside 3, and then a definite integral from 0 to pi over 2 of cosine squared of theta d theta. This answers the question as far as at least the test is concerned, because you see then you can tell that the correct answer is right here from this step. But for our own benefit, you should work through the process of evaluating the integrals. So I'm going to continue with that process basically. So next what I'm going to do is I'm going to say 3 and then a definite integral from 0 to pi over 2. And the middle gets replaced with 1 plus cosine of 2 theta. And this whole thing is divided by 2. That's a basic identity for cosine squared with the d theta over here. You can pull the 1/2 outside and multiply by the 3. So it's going to give you 3/2 here, definite integral from 0 to the following. Pi over 2. And the other part then will be 1 plus cosine of 2 theta and then d theta right here. Continue down below. This is going to give us here the following. 3/2 and then you can anti-differentiate. So the antiderivative of 1 is just theta in this context. Now, I'm not going to go through the process of doing u sub on anti-differentiating cosine of 2 theta. Hopefully you know how to do that, but I just kind of write the final answer down. So think about it. The antiderivative answers this basic question. What is the function whose derivative is cosine of 2 theta? What is that function? If you just, for example, put sine of 2 theta, because the derivative of sine is cosine, that matches. But then you would have to multiply by the derivative of 2 theta, which is 2. In other words, it would look like this, which is not what we have, because we have just cosine of 2 theta. So you have to cancel that by doing 1/2 in front of the whole thing like this. Take a look. I'm going to put here 1/2, and then out here, the upper limit is pi over 2, and then down below is 0. And then you basically evaluate this. So 3/2, and then you're going to do pi over 2, and then plus 1/2, and then sine of 2 times pi over 2, and you're going to subtract off from this the following. 0, and then plus, and then 1/2, and then sine of 2 times 0. continue, so it's going to be 3/2, and then pi over 2 plus 1/2 of sine of pi. The 2's cancel. This is a pi over here. And then minus 0 plus 1/2 again of sine of 0. Continue here. It's going to be 3/2. It's going to be here pi over 2. And then plus 1/2. Sine of pi is 0. It's the y coordinate at 180 degrees on the unit circle, or pi radians. And 1/2 times 0 is just 0, so that goes away. Minus. This is 0, and then again, sine of 0 is 0, 1/2 times 0 is 0, so it's basically you're ending up with something like this, which means at the very end the answer is just basically 2 times 2 is 4, and then you multiply by pi, and this would be the actual value of the integral. If you did want to provide a polar representation, then basically 2 cosine theta represents a big circle like this of radius 2, and a smaller one would be a circle that looks like the following, kind of like this. You see, it's got to be a circle, and then just move this into position. And what we have just found is the area between them, so that means the following specifically. This is what we have just found. The value is 3 pi over 4. This is the polar representation of the shapes. Sometimes we kind of shade it this way, you see? And that is it. So friends, if it's been helpful, please leave a like, please subscribe. Thank you so much for watching. I will see you in another video.